This code snippet imports essential libraries for financial data analysis, including those for data retrieval, manipulation, statistical analysis, visualization, technical analysis, Excel output, and data time handling. It utilizes the following libraries and modules: 1. Stats models, regression, rolling used for performing rolling window ordinary least squares ols regressions. 2. Pandas data reader, data fetches financial data from online sources, commonly used for retrieving stock price data. 3. Matplotlib, pyplot enables plotting visualizations like charts and graphs. 4. NumPy provides support for large arrays and mathematical functions. 5. Pandas offers data structures for data manipulation, especially useful for handling structured data. 6. Writer used to write data, formats, and formulas to Excel files. 7. Math provides mathematical functions following the C standard. 8. Finance fetches historical market data from Yahoo Finance. 9. Pandasta extends Pandas library with various technical analysis indicators. 10. Data time supports manipulating dates and times. 11. Warnings, Python's built-in library used to manage interpreter warnings, suppresses warnings through warnings, filter warnings ignore. The code sets up the environment for financial analysis and suppresses warnings to streamline code execution. The provided code performs the following operations: 1. Retrieves SP500 company symbols from a Wikipedia page using HEAT. 2. Replaces periods with hyphens in the symbol column. 3. Extracts unique symbols and converts them to a list. 4. Sets the end date as 2023-12-15 and calculates the start date 8 years prior. 5. Downloads historical stock data for the symbol list from Yahoo Finance using Finance. 6. Reshapes the data by stacking to create a multi-index data frame with date and ticker. 7. Renames index levels to date and ticker. 8. Converts column names to cloud-arrays. This code snippet facilitates the retrieval of historical stock price data for SP500 companies within a specified date range. It transforms the data into a structured data frame for analysis and further processing, utilizing Pandas and Finance libraries for efficient data handling in Python. The script utilizes the Finance library to gather details about a specific stock symbol, Apple Inc., from Yahoo Finance. The process involves 1. Creating a ticker object for the Apple symbol. 2. Using the info method to acquire company information for Apple Inc. 3. Extracting the market capitalization market cap and current stock price current price to support further examination or application. The purpose of this code is to access recent financial data, including market capitalization, current stock price, historical prices, and other pertinent information. This data can be crucial for analysis, visualization, decision-making, or any financial use case associated with a given stock. The following code creates an empty data frame in Pandas and specifies the column names as ticker, stock price, market cap, number of shares to buy. The PD data frame method is used to define these columns in the data frame. The variable restif is assigned to this newly created data frame. This approach is beneficial for establishing a data frame with predefined columns, allowing for easy data population later on. It aids in maintaining a structured data frame, simplifying data management and manipulation tasks. The variable restif is likely a Python object or variable name, though its exact functionality is unclear without further context. Typically, restif might represent a result data frame, potentially indicating that it stores the outcome of computations or transformations applied to a data frame in Python. Data frames, popular in libraries like Pandas, offer structured data manipulation and analysis capabilities. Understanding the specific role and necessity of restif would involve examining surrounding code to discern its generation or utilization. It could be holding computed results, filtering data, or preparing information for subsequent analysis. The specific tasks and context tied to restif within the code will clarify its intended purpose and relevance. The following code snippet illustrates how to store financial data for multiple stock tickers into a Pandas data frame using the Yahoo Finance APIs. Below is a summary of the code's functionality. 1. Initialize an empty data frame restif with specified columns. 2. Convert a list of stock symbols into a string format. 3. Utilize the Yahoo Finance API to fetch data for the stock symbols provided in the string format. 4. Return the symbols string for potential further user reference. By leveraging this code, financial data for various stock tickers can be efficiently retrieved from the Yahoo Finance API and organized into a structured data frame. This enables easier analysis and visualization, especially when handling a large number of stocks, simplifying the data retrieval process. This code snippet iterates over a list of symbols stored in symbols list. For each symbol, it retrieves information, market capitalization, and current price from the ticker's dictionary using the symbol as a key. It then appends a new row to a data frame called restif, which includes the symbol, price, market capitalization, and finally, the updated data frame is returned. This code is beneficial for extracting specific data for a set of symbols and arranging it in a structured manner within a data frame for further analysis or processing. Operating on this data frame facilitates efficient handling of the data, enabling tasks like filtering, grouping, or exporting it to different formats. This code prompts the user to input their portfolio size, attempts to convert the input value to a floating point number using the float function, and assigns it to the variable portfolio size to handle possible value error exceptions that may occur if the input cannot be converted to a float. The code includes a try except block if the conversion fails, indicating that the user did not enter a valid numerical value. A message is printed out prompting the user to enter an integer. This code is crucial for ensuring user input is in the correct format, thus reducing the likelihood of errors when processing numerical values, thanks to its effective exception handling. This script is designed to evenly distribute the total value of a portfolio among different stocks by calculating the number of shares to purchase for each stock. Here's an overview of how it works. 1. It sets the total portfolio size to 1, 0, 0 and calculates the position size by dividing the portfolio size by the total number of stocks in the dataset. 2. It then loops through each stock symbol in the symbols list and computes the number of shares to buy for each stock based on the stock price. This is done by dividing the position size by the stock price retrieved from the restif dataset and rounding down using math. 4. To obtain the nearest whole number of shares. 3. Finally, it updates the restif dataset with the calculated number of shares for each stock. This piece of code is particularly valuable in quantitative finance and algorithmic trading for efficiently managing and optimizing capital allocation among a variety of stocks in a portfolio. By evenly spreading the total portfolio value across different stocks, it aids in maintaining a balanced allocation and mitigates the risk of any single stock significantly impacting the overall portfolio performance. This code snippet exports a pandas data frame restif to an Excel file named trades, in a sheet called trades. Here's a breakdown of its functionality. 1. By using Excel writer trades, engine equals writer, an Excel writer object is created to facilitate writing data to an Excel file named trades. Using the writer engine, which offers enhanced features compared to the default pandas engine. 2. Following this, restif, Excel writer, trades, index false writes the data frame restif to the Excel file via the Excel writer. The data is specifically placed in a sheet named trades within the Excel file, and the parameter index false ensures that the data frame index is not included in the exported Excel file. This code snippet proves useful for exporting data from a pandas data frame to an Excel file. The utilization of the writer engine enables users to benefit from additional capabilities for cell formatting, chart creation, and more, thereby facilitating a higher level of customization as opposed to alternative engines. Ultimately, this code simplifies the process of transferring data from Python to Excel, thereby enabling efficient sharing and analysis of data in a different format. The following code provides 3 distinct cell formats for Excel file data input, each specifying font color, background color, and border style. 1. String format utilized for standard text or strings. This format features white font color on a dark blue background with a border. 2. Dollar format tailored for currency values. This format showcases numbers with a sign and 2 decimal places, in addition to white font color on a dark blue background and a border. 3. Integer format designed for integer values. This format displays numbers without decimal places, employing white font color on a dark blue background and a border. These formats ensure a consistent and visually appealing appearance in the Excel file. By applying these predefined formats to cells, the code guarantees uniform and clear data representation, facilitating easy readability and interpretation for users accessing the Excel file. This piece of code likely functions as part of a script designed to format and input data into an Excel file using a Python library such as OpenPickle or Ghostwriter. The script seems to be focused on structuring specific headers in the trade sheet of the Excel file, applying different formats to each. For example, the ticker header is formatted with the string format and placed in cell icons. Stock price and market cap are both assigned the dollar format and written to cells bone and cone, respectively. Number of shares to buy is given the integer format and placed in cell done. This methodical formatting and organization of data are particularly beneficial when handling extensive datasets that necessitate orderly and consistent structuring, as seen in financial reporting, data analysis, and other scenarios where data is presented in tabular form. This code defines the formatting for columns in a spreadsheet using a dictionary called colformats. Each key in the dictionary represents a column letter, and the corresponding value is a list containing the column name and format to apply. The script then loops through the keys of the colformats dictionary to set the column width and format using the setToLon method on the trade sheet object. It also writes the column name in the first row of the specified column. This code streamlines the process of applying customized formatting to different columns in a spreadsheet, enhancing the presentation and readability of the data. It automates the application of predefined formats specified in the colformats dictionary to each column. The writer close method is used to properly close a file that has been opened for writing. When you have finished writing to a file and no longer require any further modifications, it is crucial to close the file. By closing the file, you ensure that any buffered data is correctly written to the file. The file object is appropriately released, and resources associated with the file are fried up. Neglecting to close a file after writing to it can result in data loss, resource leaks, and potential problems with file permissions. It is considered a best practice to always close files once you have finished working with them to avoid issues and to guarantee that your code is both clean and efficient.